This is unit 7, chemical reactions. In this one, there are 4 subtopics. There is 7.1 physical and chemical changes, 7.2 rate of reaction, 7.3 reversible reaction, and 7.4 redox reaction. I'm sure most of you have learned redox in grade 9 and some idea about reversible reaction as well. But we will revise those concepts again. So the first one subtopic is we have to learn about the physical and chemical changes. We have to identify what is a physical and chemical change, and then we have to understand, we have to list out the differences between these two. So what is a physical change? In your point of view, from your idea, can you tell me what is a physical change? Just mention in the chat. What do you think a physical change is? Just with few words, can you describe what is a physical change? You can mention an example as well. Yes? Anyone? Change through the appearance of an object. Well, that's not wrong. Yes. How appearance change? Change state, melting or boiling point. Yeah, Nabaha answer is much more linked to science. Yes. Now, when we say appearance, that appearance have different meanings, right? So it can be color, it can be state, it can be physical. Uh, uh, the physical aspects of it, for example, whether it is hard or soft, strong or weak, brittle or malleable. Yes, good answers. Yes, physical change, the substance present remain chemically same. No new substance are formed. Yes, I think, yeah, you got some idea. So a physical change does not produce any new chemical substance. When that particular substance undergo physical change, its chemical composition, which means what it is made up of, the elements that it is made up of, is not changing. For example, water, before it will be ice cube in solid state, but when changed into liquid water, it's still made up of H2O molecules. In ice cube also, it's made up of H2O molecules, hydrogen and oxygen. Only the thing is the arrangement of the molecule is changing. So in a physical change, the chemical elements, the chemical composition does not change, but the arrangement of the sub molecules change, arrangement of the atoms change. So that arrangement, when it is changed, then we say it is a change of state, melting, evaporation, condensation, etc. Okay, these changes are often easy to reverse, and mixtures produced are usually relatively easy to separate. So when you change water into steam, you can condense that steam and then you can uh, reverse the process which was done before. That was evaporation. So like the process that you have done, the physical change can be reversed easily. So as you can see from this example, you have sulfur and iron fillings. When you mix the iron powder with the sulfur, there is a physical change. There is no new substance formed. Iron sulfide is not formed, right? They just mix together. If no new substance is formed, means that they are not dissolving, right? But when compared to chemical change, for example, as you can see in the picture, there is a combustion reaction that is going on. If you heat the end of in a Bunsen burner and push it into the mixture, that is the iron and sulfur mixture, the mixture starts to glow brightly. There is a chemical change that is going on. So in a chemical reaction, new chemical products are formed, and they have very different properties than the reaction. So for example, hydrogen H2, hydrogen gas is colorless. Oxygen O2, oxygen gas is colorless. When those two combine, there is an explosive reaction which produces water, H2O, which is a liquid, a total new compound, and have new properties compared to hydrogen and oxygen, which it is made up of. Most chemical reactions are impossible to reverse, or you have to project that substance into very high conditions in order to reverse. So it's not that easy. Energy changes also accompany chemical changes. So in a chemical reaction, there's always a change of energy from environment to the reaction, or from the reaction to the environment. If from the reaction heat is released or heat is given out, then it is called exothermic. Okay, it's called exothermic. But if heat is taken into the reaction from the surrounding, then it is called endothermic. So exothermic means heat is released into the surrounding, to the surrounding. Endothermic means heat is taken in from the surrounding. So in exothermic reaction, always you will feel the reaction hot because energy is released into your hand. But in endothermic reaction, you will feel the test tube cold because energy is taken in from the surrounding. So far so good. Any question? Take a look at to this to the surrounding. The heat it dissipates into the surrounding. So take a look at to this photo. Burning gas to fry eggs. Is it a chemical change or physical change? Can anyone answer? Burning gas to fry eggs. Is it a physical or chemical? Okay, first, there's two things that is going on here. When you burn gas, there is obviously a chemical change, right? Is it is it is it correct? When you burn a gas, is it a chemical change? For example, from your gas stove. Yes, it is a chemical change. To be specific, it is a combustion reaction in which the gas, which is an alkane, more specific butane that is stored in the gas bottle, is reacted with oxygen in the air, combusted in oxygen in the air. So it is a combustion reaction, a chemical change. When you fry the egg, it is a chemical change. Or if it is a physical change, it will change state, right? For example, when you heat something in liquid state, it should change into gas. So egg is in liquid state. If it is a physical change, it should change into a gas. But what are you doing is, when you heat the egg, you are supplying heat to the chemical bonds in the egg. All right, you are supplying heat to the covalent bonds, and when eggs are fried, they absorb heat, which breaks the weak chemical bonds in the particles of the egg, and they curl up, or you can say they rearrange in a specific way, so that it is changing into a solid state substance, or what we see as a solid state. All right, so these are the things that you have to be very mindful of. So it's a chemical change. In a chemical change, always remember three things happen. One or more new chemical substance are formed as a product. Energy is taken in or given out, okay, during the reaction, which means it will be either exothermic or endothermic. No, I just mentioned the egg is going into a chemical change. It gains heat, the bonds are broken, and new substances are formed. All right, that new substance is in solid state. That pretty much summarize what happens. Yes. And the third thing is, the change is usually difficult to reverse. It will be difficult to reverse the omelette into back to egg form. Do you agree? Okay. So with that, we have to start with the idea of, once we know what is a chemical change and the physical change, usually a chemical change is mentioned as a chemical reaction. So it is called a chemical reaction. But what is rate of reaction? I think you might have learned about rate of speed from physics, right? What is rate? So we will be discussing these points. There's quite a lot that we'll be learning under rate of reaction, but mostly they are very simple. It's not that difficult compared to other topics. So very straightforward concept. So we will learn about um, yes, how quickly the reaction take place. Yes. We will learn about concentration, particle size, catalyst, temperature. As you can see, pressure is not here. In previous syllabus, pressure was mentioned, but in your syllabus, pressure is not there. We will be learning about the application of explosive combustion, and we will be learning about how to interpret data from graphs concerning the rate of reaction. We will be learning about the practical method of investigating rate of reaction, and we will learn about different variables for the rate of reaction, and you will have to describe and explain the effects of these variable, that is temperature, concentration, catalyst, particle size, on rate of reaction. All right, so basically these are the key ideas that you have to learn. So what is a rate of reaction? So one student mentioned, Aban mentioned, how quickly the reaction take place is the rate of reaction. So how quickly or how slow? All right, it's not only about the how fast it is. So if you take a look at to these three animation, you can see the first diagram. It is uh, it is a combination of sodium chloride and silver nitrate. What do you think will be formed? Silver nitrate and sodium chloride solution. Silver chloride is insoluble in water. That's why you see the silver chloride, which is white colored precipitate. Yes, precipitate. That's why it's a cloudy. Okay, when from a reaction from a clear solution, if a precipitate is formed, usually it is seen as a cloudy solution. Okay, so this, as soon as the drops is uh, the drops of silver nitrate is added to the sodium chloride solution, immediately the reaction starts forming silver nitrate, silver chloride. But look at the second one below. There is copper coil, and silver nitrate solution is added. What do you think is happening here? Can anyone describe what is the name of this kind of reaction? Copper is reacting with silver nitrate, and you can see the silver from the silver nitrate, not crystallization. The silver from silver nitrate is getting deposited around the copper coil. Anyone? No, not electrolysis. It is not connected to electricity. No, it is just the copper coil is placed. That's it. Not connected to any power source. Think about the reactivity series. Copper is above silver. So copper is reacting with silver nitrate. So what's going? Yes, displacement reaction. Actually, we can do this in our school lab as well. So next time when the school open, we will do this experiment. It's a very nice experiment. But the thing is, you have to wait for 2 or 3 hours in order for the result to see. You can see very nicely the silver is formed around the coil of the copper, because copper can displace silver from silver nitrate. The silver is the one which is being displaced around copper. Okay, so it's slower than the first one, but there are reactions which is much slower. Can you tell me what's going on here? It is mentioned, right? Rusting of steel. So a steel started to, so from January, February, March, April, May, around, so it took around 1 month to oxidize or to rusting to form, to rusting the reaction to occur. So this is a very slow reaction, but still there's a reaction going on. So no matter how slow or how fast, the reaction is going on. So what is rate? Rate is a measure of how fast or how slow something is. So reaction means, rate of reaction means how fast or how slow a reaction occurs. Rate is a measure of the change that happens in a single unit of time. So in terms of chemical reaction, how fast the products are formed in terms of time. All right, time is the main factor here, and the other main factor is the amount of the products formed in a chemical reaction. Take a look at this example. As you can see, the first one here, it is zinc added to sulfuric acid. So a metal is reacting with an acid, which means hydrogen gas will be formed, right? Hydrogen gas will be formed. So if a gas is formed, you will see the observation for the reaction will be bubbles or effervescence. So zinc and sulfuric acid, they react together. The zinc disappears slowly. Why? Because zinc is reacting with sulfuric acid to form zinc sulfate, and zinc sulfate is soluble in water. So you don't see any zinc sulfate because it will be clear solution since it is soluble. But you can see the bubbles given off because hydrogen is formed. So as time goes by, the gas bubbles off more and more slowly. This is a sign that the reaction is slowing down. Finally, no more bubbles appear. That means the reaction is over. So usually this is kind of question that can be asked in the past paper as well. How do you describe when the reaction is over? How do you know when the reaction is over? When there is no more bubbles. Okay. So rate of chemical reaction is the gas that bubbles off is hydrogen. So if you take a look at the equation, zinc plus sulfuric acid given rise to zinc sulfate plus hydrogen. This is the equation for the previous reaction. You could measure the rate of the reaction for that particular reaction by measuring the amount of zinc used per minute. So amount can be the mass of zinc. You can first measure the mass of the zinc that is used for the reaction. So as time goes on, for example, 1 minute, 2 minutes, 3 minutes, you can record the mass of the content. All right. The amount of sulfuric acid used per minute. You can measure the amount of zinc sulfate produced per minute. The amount of hydrogen produced per minute. Among these four, which one do you think will be more easier to identify? Which amount of which substance will be more easier to identify and why? Can anyone answer? You can unmute, you don't have to. Yes, Southern gave hydrogen. Amount of hydrogen because it is a gas. So since it is a gas, Nabaha, since it is a gas, why do you say it is easy since it is a gas? How can we find the amount of a gas?
Because we can use something like a gas syringe to measure the amount of gas evaporated.
Yes? How can we find the amount of a gas? Gas syringe. Okay. Yes, we can find the amount of a gas uh, by measuring its volume. The volume of the gas is the amount. All right. So to measure the volume, we can use gas syringe. And gas syringe is not only the apparatus. You can use gas jar as well. With some gas jars contain the scale. You can use those gas jars underwater. I think you might have heard about water displacement. You can use that method as well. So for this reaction, it is easiest to measure the amount of hydrogen produced per minute since it is the only gas that forms. It can be collected as it bubbles off and its volume can be measured. Uh, let's watch a video. Can you hear?
Hello again. Do you know how to define the term reaction rate? And do you know why reactions all occur at different rates? Amira will tell us more.
Let's take a look at another experiment. I have a concentrated acid solution in this test tube, and I'm adding strips of aluminium. There are bubbles forming, so there must be a chemical reaction taking place. Chemical reactions only occur when molecules collide with each other to form new molecules. These collisions are called effective collisions. For effective collisions to take place, particles need to have just enough energy, and they need to collide at just the right angle. For some reactions, the products form quickly, while in other reactions, it may take a long time. We say that the rate of reaction is different for these reactions. We define the term rate of reaction as the amount of product formed per unit of time. The rate of reaction is dependent on the number of effective collisions taking place. When a large number of effective collisions occur in a specific time, more products form and the rate of reaction is high. But when the number of effective collisions in a given time is small, fewer product molecules form, and we say the rate of reaction is low. When we have a certain number of reactant molecules, the fixed number of product molecules will form too. We can never change the amount of product formed. We call the amount of product the yield of a reaction. However, we can change the time it takes for the product to form.
So, what did you understand from the video? Anyone? What did you learn from the video? Have you heard something called collision? Did you heard something about it? Yes. So when we are talking about reactions, what is the link between collision of particles and reaction? What is it? What is the link between those two? Kinetic particle theory? No. Well, when collision occurs, reaction happens. Amount of effective collisions per second. Collision of the particles reacts. Particles react when they collide with each other. Yes. Oh, so I think you got the correct idea, but still missing some important point. Okay. So the collision theory says, in order for the particles to collide with each other, and the collision must have enough energy. So in order for the collision to occur, the particles first should have enough energy to collide, right? If you are going to hit someone, you have to have some certain amount of energy. I'm not saying do it, okay? I'm saying if you have to hit someone, if you have to fight someone, you have to have enough energy to do it. So for the collision of particles also same idea applies. So first there should be enough energy to do it. And in order for the reaction to occur, there should be successful collision. Now, particles may collide, but there might not be any reaction. So the particles should collide in correct arrangement. then only the collision occurs. So only collision is not enough. They have to collide in correct orientation or correct arrangement. So first I mentioned is about the energy. Particles should have energy. The second is the particles should collide. And the third is the particles should collide in correct arrangement. All right. So look at the diagram here. So we have acid, water molecule, and then we have magnesium. So it is a reaction in which magnesium metal is reacted to acid. So if it is a dilute acid, there will be water molecules, there will be acid particles as well. Now, even concentrated also water molecule will be there, but the amount of water molecule will be less. Here in this case, the amount of water molecule is high. That's why I mentioned it is dilute. Okay. So the particles in liquid move non-stop. We know always in liquid particles are moving. To react, an acid must collide with magnesium atom. So the acid particle must collide with magnesium atom and the bond must be broken. Which bond it is mentioning? The acid particle colliding with magnesium and the bond must be broken. Which bond it is mentioning? Can anyone tell me? In magnesium, what is the bond in magnesium metal? What is the bond inside a metallic bond? Yes, very good. So if you look at the second diagram, you can see that one atom of magnesium is reacting or colliding with the acid particle. All right, and this collision has enough energy to break the bond. So it is a successful collision. The particles react and new bonds are formed, forming magnesium chloride. If the acid we are talking about hydrochloric acid. But this collision in the third diagram, in here the particles collide and bounce back. Just did not have enough energy. It was not successful. No bond were broken. The acid particles just bounce away. So they should have enough energy to collide and they should collide in correct way. Then only the reaction occurs. That is what the collision theory is all about. All right. The particles should have enough energy to start a reaction. There is a specific name given for that. It is called activation energy. Okay. The energy, that is the minimum energy that is required to start a reaction, which is called the activation energy. So we will be highlighting about that as well. So there are different factors for rate of reaction. We will highlight these points after about 5 minutes break. So mole over volume, right? Mole means molecule, molecules over volume. So that means in a specific volume, how many molecules are there? That is concentration. So it is related to the number of particles. So increase in the concentration means the rate will increase. This is because there will be more reactant particles. So here in this example, there will be more oxygen in number 2. The diagram 2, there, since there is more oxygen, the flame burns brighter, allowing more frequent and successful collision. So when there is more particles, there will be more chance or more frequent collisions, right? So more frequent collision means there is more chance of successful collision. More successful collision means more reaction is going on, which means rate of reaction is increasing. So low concentration and high concentration, that is the difference. The next is the effect of surface area. So look at the diagram here. And can you tell me what's going on in these two diagrams? Diagram 1 and diagram 2. What's going on here? You can see those particles arranged in regular form. Some particles are in blue color and some particles are in black color. Why do you think so? More surface area allow reaction to happen faster. But how? How it more surface area allow it? Yes, Nabaha, very good. First diagram, less number of particles are exposed to the reaction in diagram. Yes, more surface is how much it is exposed. So you can see the blue colored ones, right? These blue colored ones are the one at the surface of that substance. These are the particles that are first exposed to the reaction, to the substance that is reacting. All right. But if you check the second diagram, these particles, the blue particles, will be the one which is exposed first. So that surface area is included. But if you take 1 and 2, same amount, same number of atoms are there in terms of those black and blue colored ones, right? Same number of black. In fact, the black one is less in the second one. But the blue one, it is available for the reaction is much greater. Which means the surface area increase when you make the particle into smaller size. When you make the substance into smaller size compared to large size. Larger size has less surface area compared to smaller size. That's the main idea here. Okay. So increase in surface area in the solid state, the reaction will increase. This is because more surface area, more particles are exposed to the reaction. So there will be more frequent and successful collision, which will increase the rate. All right. If you take a look at how a smaller particle contributes to greater surface area, you can check from this diagram. Now, what's happening here? Can anyone tell me? Diagram 1 and diagram 2. Diagram 1, the particles are slowly moving like when you wake up in the early morning. And diagram 2 is just like you after the interval time or when you are about to go to the interval time. Yes, very good, Malak. So it's related to temperature. Yes. Increase in the temperature, increase the rate of reaction. This is because the particles will have more kinetic energy. So kinetic energy means the energy that is required to move or move in substance, move in energy, we can say. Required then the activation energy. Activation energy is the energy that is required to start a reaction, the minimum amount of energy that is required to start a reaction. So they will have higher kinetic energy than the activation energy. Therefore, they will move frequently, they will move faster, more frequent collisions will be there, more successful collision will be there, so the rate will increase. The next is effect of catalyst. Now, catalyst is something unique. When you use a catalyst in a reaction, it will not react with other substance in the reaction, but it will create a way for the reaction to proceed in a much faster speed. So catalyst, what catalyst do is it reduce the activation energy, that is the energy required to start a reaction. So there will be other particles. Those particles, if they have enough activation energy, the catalyst will decrease the actual energy that is needed to start a reaction. It will lower the activation energy, which result in more collisions, more successful collisions, so therefore the rate increase. So take a look at this reaction in this diagram. A glowing splint is used with hydrogen peroxide solution. Now, glowing splint, we all know, it is used to test for hydrogen gas. When hydrogen peroxide breaks down or decompose, it produces oxygen and hydrogen gas and water. But hydrogen peroxide itself will not decompose. You have to use a catalyst. So here the catalyst is manganese 4 oxide. What the manganese 4 oxide is, it will lower the energy that is required to start the reaction, so that the reaction can start much more easy. And when the hydrogen peroxide is decomposed, hydrogen gas is released, and glowing splint is actually used for oxygen, not hydrogen, right? So oxygen gas is released in this case. So if it is oxygen gas released, then the glowing splint will relight. Okay. You can also use raw liver as a catalyst for this reaction instead of magnesium 4 oxide. Now you can represent this idea, this decrease of idea, in a graph. If you take a look at this graph, do not worry, there are so many stuff here going on. Just look at the graph from left then to right, okay? Because it is the direction in which the reaction is progress. So let's see, reaction starts from here, okay? It progress. At this level, the reaction does not start. Reaction start actually from here, when the particles gain enough activation energy. This is the activation energy. This part is the activation. So this distance, this much energy is required in order for the reaction to start. But what the catalyst do is, it decreases the activation energy. As you can see, the activation energy is lowered. In this case, with the catalyst, it is only this much is required to start. So it is more likely the one with the catalyst will reaction to start faster, and then it proceed to form products. Okay. So next is the idea of investigating rate of chemical reaction. This I will be explaining in next class. So this will be more towards the idea of experimental chemistry. All right, mostly paper 4 type questions will be asked from this topic. Paper 4, I mean paper 6 type questions. Okay, alternative practical type questions. So up to now, we have discussed about the physical change, chemical change. We discussed about the collision theory. We discussed about chemical reactions. We discussed about the factors of rate of reaction. So up to here, anyone have any doubt? Any question to ask?